So, Andy, I'm going to read your intro here while you bring up your slides. Andy McNamara is the co-founder and principal at Carbon Zero Buildings, a general contractor focused on multifamily electrification retrofits. Andy and his teams have successfully executed over 40,000 units and $40 million in multifamily energy retrofit construction projects in California over the last 7 years. Over 2,000 units were multifamily electrification retrofits. So truly, perhaps the most experienced single human being in California at electrifying existing buildings or multifamily buildings. Welcome, Andy. Thank you so much for sharing your wisdom with us.
Thanks, Sean. Thanks for having me on. I put together a few case studies here to run through, and I guess first I should make sure sound and video check. Am I coming through clear in our?
Yeah, you sound great. Your slides are there.
All right, perfect. Yeah, cool. So so put together a few case studies here to run through of multifamily electrification retrofits, which I have been working on since about 2017, and we'll run through those. So just, my company, our mission to rebuild California's multifamily buildings with zero carbon solutions, just founded last year, and we're headquartered in Oakland. Cool. So I thought I'd just start with kind of a quick level set on technologies for electrification, and some of the technologies that I'll be focusing on in the presentation. Of course, there's a lot of different electrification technologies. So for water heating, we have heat pump water heaters, space conditioning, of course, as the last presenter was alluding to. I'm sure I don't need to go into detail with this crowd. Heat pumps such as mini splits, or multi-splits, or VRFs, and so on and so forth. I'm not going to get into induction cooking here. And then heat pump pool heaters is another measure that we've done. Haven't done a heat pump clothes dryer yet, but I would like to someday soon. And a lot of this presentation will focus on heat pump water heaters. So I thought I would just kind of orient folks with some quick nomenclature with, the different style. We have sort of more the single family style with integrated tank and split systems being kind of two of the major varieties here. So integrated tank means the condenser, or the compressor rather, is actually integrated into the tank, usually at the top of the tank with the water storage below. Our split systems have the condenser compressor separated from the tank. So the tank is just a pure storage tank. And then, you get into some of the larger format units. This is a Sanco unit pictured here, which is, as Sean puts it, intended to supply a Japanese soaking tub, very high volume of hot water. But it also works great for serving 4 units of multifamily, or ganging them together, and serving maybe 16 or 20 units of multifamily. So even though it's a quote unquote single family technology, we still use it in multifamily. And then, as shown in the residential manifolded line here. And then we've got the larger split units, such as, Mitsubishi, Rheem. I mean, I'm going to the AHR Expo on Monday, and I'm excited to see the new offerings, because last year when I went, it just felt like everyone had landed in the California marketplace with something. Link and Lochinvar and A.O. Smith and all the big boiler manufacturers are showing off their heat pumps. So I want to see how they've progressed in the past year. And there's lots of activity there on the large split systems, and there needs to be, because we need more and better options that are quieter and so forth. But we have experience with a good number of those. So just a timeline of my experience, and a lot of this is when I was at Bright Power, where I was through 2022. So from when my career started in 2006 to 2017, I didn't do any electrification, but I did a lot with multifamily building energy. And then just to kind of roll through kind of a timeline of the projects, worked on some projects with Mercy and Bayside, where we did some of those Sanco split systems, rolled through to some Colmac systems for Jonathan Rose companies, and again Colmac here for these EAH properties. For TNDC, we did some Colmac projects as well. This was a Sanco in Oakland, a Sanco project manifolding 12 of them together. So that's the smaller format unit. And these are all retrofits of existing multifamily. Most of them are low rise, some are mid rise and high rise. And we'll get to photos and all that shortly as well, but I just wanted to give you a broad brush. There's a few more here. I'm not going to like tell the story of every single one. You know, there's a large Sacramento project here that I'll get into later where it's a full electrification retrofit where we removed gas, which is a fun one. So we'll get into that shortly as well. Cool. So, thought I'd start with some of our first multifamily heat pump water heater installations here. This one's on a rooftop in Oakland. It was 7 affordable multifamily properties between 36 and 151 units, and we manifolded sand and heat pumps together. Now Sandco. They've rebranded as Sandco and spun off, but it's a similar unit, improved actually from these days because they've progressed to Gen 4, I think now. And we installed these on the roof, and in some cases in really big boiler rooms that were cavernous that had areas to the outside. So we really liked the form factor of the Sandon unit. Here was another property where we were able to squeeze them into a breezeway. You know, so here you can see how we've squeezed them into a narrow area. Actually happened to be the exhaust outlet for the steam boiler, so we got some free heat there, which was nice. Not like the actual exhaust went up to the roof, but there was some waste heat in that room that just kind of was seeping out through the louver, so we were able to take advantage of that. We learned some lessons on those initial installs as well, where we struggled with recirculation and learned a lot about, I think it kind of laid some of the foundation for swing tanks as the preferred strategy, or really the isolation of recirculation. When you're doing a heat pump water heater system, you really need to isolate recirculation from the heat pumps, particularly a single pass heat pump like a Sandco, because the Sandco is really happy and has a high COP and also its highest output when you're giving it 60-degree, 50-degree inlet water, which is the temperature of incoming cold water. And it likes to heat that up in a single pass to 150 degrees. Really low flow, like each Sandco moves 0.3 GPM, but it does a high lift. And when you disrupt that and you take recirculation water that's coming back at 100 degrees, it really screws it up. And actually, not just the efficiency, but also the capacity, meaning you can't deliver as much heat, and also the ability to heat up mid-temperature water. We found that by the time you get to 115, 120 degree return water, there may not be the minimum temperature to allow that heat pump to even turn on, right? Learned that lesson the hard way in 2017, and that's, you know, why we don't return recirculation to primary. We return it to a separate tank, because otherwise you can really get yourself into trouble. And this slide, I think, was a vestige. I'm sorry, I think that got stuck in there, and it wasn't in regard to this project. With these projects, these initial Mercy projects, we actually used a pre-existing gas-fired swing tank, which is a hybrid design, kind of like a swing tank would be now, where you use electricity. In those days, we kept the existing equipment they had on site, and we utilized the heat pumps to preheat that, and then the gas boiler was kind of our gas peaker plant. Today, we're not doing that sort of thing. We're putting in an electric swing tank, but that had its advantages in terms of reducing the costs. And so that's pictured in green there. We learned a lot of lessons about crossover flow and recirculation imbalance. So one of the things with multifamily, with old multifamily, is this thing called crossover. And crossover flow is in an old multifamily building. We like to think of hot and cold water systems as separated from each other, but in reality, there's a very thin line that separates them, and that's often like a single lever shower valve in every single apartment and other places in the apartment too. And when the gaskets inside of those places fail, if there's a pressure difference, if cold is at a higher pressure than hot, then the cold will flow over into the hot water system, and then that'll manifest as wherever that crossover is happening in the next unit over, they'll experience colder hot water than they would like. So what maintenance managers do, they know how to resolve this. You can just crank the Recirc pump higher, you install a bigger Recirc pump, or you crank up the temperature of the boiler, and then you symptomatically address the crossover flow by whisking it away with a recirculation pump. That doesn't work super well with heat pumps. And in the most extreme examples, you can get with crossover flow, it can become a very significant proportion. I did a study for NYSERDA on solar thermal systems where we proved that at one building in the Bronx, over 80% of all incoming cold water to that particular building was coming in through crossover. We did the installation of flow meters and showed that indeed so much of the water was coming in through crossover. Most buildings aren't that severe. There's been studies of California buildings that show, I think it impacts maybe more like 30% of California buildings in any kind of significant way, but it is something that you need to be aware of because it can impact. And that's why you want to do a crossover test before you install, so you know the magnitude of crossover, so that you can design appropriately and maintain a high COP, because otherwise you can end up with a system that costs a lot to operate. Always like this slide of kind of where electrification is going. There's a lot of parallels to transportation. So we started with a lot of high efficiency gas retrofits, and then in our early days we did kind of the hybrid car, where we still had the gas there just in case things didn't quite work out, and now we're really moving to the full electric solutions. So we'll move along to another case study here of a Colmac install in Panorama City, California for Jonathan Rose Companies. Again, this was done in my time at Bright Power. We worked with the folks at Colmac, Kevin Green, Brian Culler, not sure if they're on the line today, but got these installed. These were a preheater. We kept the gas peaker plant in place, so we're still using that methodology. Looks like I left off the title slide on this one. Apologies. This is another project. This is another project where we actually had to fit these Colmac units into a property in San Francisco. So getting these big units into San Francisco, this was a fun project where we had to keep the boilers online. Of course, that's always a trick with existing multifamily, is like people continue to need the heat and hot water while you're building the plant. So we had to take these out one at a time and then make our cutover within the same day, so that there was never a loss of domestic hot water, and we were able to do that. And then we were also we removed the boilers. We still had a gas peaker plant. We just took a loop off of the domestic hot water line for this one, or for the off of the space heating boiler. We took a line off of that, so we were still doing kind of a hybrid solution here. One challenge we had with this one that I thought I'd share is after we installed it, we had noise complaints, where the amount of noise ejected from inside of this room out of this louver over here was actually causing people in the street to complain. And it turned out that this unit was producing, we were measuring 85 decibels outside on the street. And we worked closely with Colmac. We retrofitted in a variable speed fan to reduce that noise level. But venting is challenging because the ducts are so big. You can see how big this ductwork is, and these units move a lot of air to suck the amount of heat that they need to suck out of the air, because they're pulling that heat out of the air. They're moving a lot of air to do that, and the ductwork ends up being very large. I can't remember exactly the cross-sectional area, but it was certainly the size of this louver. And so you can imagine how difficult it is to move that through a crowded boiler room. So you always want to have it very close to the outside wall, but then it also can bring up these noise concerns. And so I think more and more units are lowering the decibel levels, which is good to see. We were able to get there with Colmac with a variable speed fan, but I know Colmac has gotten better, I think, on their base specification, and there's more and more units that are available with lower decibels. But that's definitely something to consider on projects, is what is the decibel rating of that product. So moving on to kind of some full electrification. So here's a project in Sacramento that we recently worked on. Again, I worked on this during my tenure at Bright Power, but it was a full electrification scope. So no gas left at the property after this one was completed. So With this project, we installed heat pump. We installed heat pump water heaters at each building, heat pumps for heating and cooling with per unit control. So a mini split for each unit. Heat pump pool heaters. We also installed new windows, new Energy Star refrigerators, LED lighting, and roof insulation. So, and when we're done, there's no natural gas left at the property. So we went from this. So here's a map of this particular property with the central boiler. So they have a boiler and chiller plant here at the center of the property, and they had a loop running around the entire property that was very old and was breaking frequently. And so with this particular property, we retrofitted it so that we put we basically went to much more localized plants. So we put for domestic hot water, we placed a domestic water heating plant next to each and every single building, and then tied that into the existing hot and cold water entry. And that allowed us to retire the existing domestic hot water loop. They used to have an underground recirculation loop that circulated around this entire property, which was immensely wasteful. And also built in the 1960s was starting to fail regularly, and the owner was having to dig up the property and patch up these roots. So for both of those reasons, that was a strong motivating factor for the owner to be able to get rid of that. The chiller was also basically held together with bubble gum and duct tape. And there was an operator of that chiller who was retiring, and they were scared to death that no one else could ever figure out how to run it. So we were able to move heating and cooling to mini splits, gave each resident control over heating and cooling, and retired that central plant as well. So here's a picture of the hot water plants that we installed, Bright Power installed. And so, you've got, for this, I think it's a 16 unit building with 3 Sandcos, and a conventional storage tank, and then an electric resistance swing tank. Now, this was before it was insulated up, but it gives you a sense. And then here are the mini splits after they went in. So the owner was opted for a more cost-effective installation. So they went for surface mounted to reduce their costs, because they were very sensitive to that out-of-pocket cost. So the surface mounted conduit there. And then you can see the condensers located outside. This was during installation, so a lot of these things got cleaned up afterwards. And then the last, I'm really breezing through these, but it occurred to me that I should say that none of these projects would have happened without the funding support from incentive programs. So all of these are incentivized, and really I have to give credit particularly to the low-income weatherization program, because LIWIP was behind every project that I presented to this point. And every project that I presented up until this Sacramento project, which also included LIWIP, was including this one, we're really low income projects, so it really has helped with that equity and electrification connection. And really market rate electrification, from my experience, is kind of just getting going, because the incentives have been so concentrated there. But since tech opened up, we've seen a lot more activity there. And it wasn't only LIWIP. I mean, there's the MCE program and BAREN program, and BAREN Bambi program, which has an electrification program. And there's just a lot of driving forces on the incentive side. And those are so necessary, because the truth about these projects is that in Sacramento, they really save operating costs, because electricity is quite cheap in Sacramento, but because electric costs are high across the rest of the state, usually what we find is that the operating cost is about a wash if you get it right. And you design the system well, you'll end up spending about the same on electricity that you did on gas. And that means there isn't a payback, because you're paying the same before as you are afterwards. And that really means that incentives are key, because an owner's going to then evaluate it only on what the cost of the equipment is versus what the cost of a regular gas-fired piece of equipment would have been. And you really need the incentives to bring it down, and the incentive programs available really can do that across much of the state. And none of these projects would have happened without that. So I do just want to acknowledge that. And then the last case study I have for you is this project, which this is a carbon zero buildings project, my new company. And it's a project a little bit unlike any I've ever done. So this one, kind of like the last project in Sacramento that I showed you, has a central boiler plant with underground piping serving all these different 17 buildings. And I got a call from, or when I got introduced to them, this HOA was suffering. They had been without hot water for 2 weeks, which I've worked in multifamily energy for 17 years, and I told them, I was like, I've never heard of anyone who's been without hot water for more than a few days. I mean, that's like a catastrophe if you're without hot water for a couple of days in a multifamily. These people are like legitimately boiling water. Like one woman, when I was walking around the property, she's like, I need new pots and pans. I kind of gave her a quizzical look, and she's like, yeah, like I've heated so much water for bathing that I've like burned out my pots and pans, which is really not a good thing. So anyway, so the story is that with all those rains that we got in early January and late December, since December 29th, they've been without hot water just over a month. And the reason is that this underground piping built in the 70s, when tree roots, got at it, then and they started moving with all the rains, then they started cracking over and over, and they kept pulling contractors out, and they spent over $100,000 in the span of a couple of weeks trying to have contractors dig 6 feet down. And I can show you, here a woman is being interviewed on the local news, and here are the contractors. When I was visiting, they were still trying to fix the leaks, and the pipe is transite, which is a mix of concrete and asbestos, so they have to have the asbestos hazmat suits on, and they're trying to repair this broken pipe and then refill it with water. And they reached a point where they said they need to abandon that system. And we came up with a plan to put water heating plants at every single building. So we categorized the buildings into the different types, and we have different plant types that we're going to put one at each building. And we were able to move really quickly thanks to our partners, and SMUD was able to move really quickly with the reservation letters, and SMUD and the County of Sacramento have been fantastic to work with. And we were able to, within 8 days of when we signed a contract with a property to install this for them, get the first plant operational. And we're working on the second one right now. And hopefully within 4 weeks, we'll have the entire property up with hot water, which is characteristically very different from most other projects that I've worked on, where usually we plan them out. And this one had kind of everything at once, engineering happening at the same time as like we just kind of had everyone on site, almost like a design charrette in real time. It's like the engineer, the contractor, the owner, and a lot of different people just kind of staring at it. Well, what if we did it like this, and like drawing with Sharpie on the walls? Well, what if we put these components here? Would that be okay? And is everyone okay with that? Okay, yeah, all right, great. And then so with that kind of integrated approach, we're able within 8 days from contract signing to get to an operating hot water plant, which was yesterday. So I've been very busy on that. And we were able to pull an emergency permit. Sacramento County was fantastic and working with us in a really expedited permitting process. We were able to get our mechanical, electrical, plumbing, and structural engineering done, procure our materials, and install them, and get the pads poured and cured well enough to have the equipment on it. So it's like a light speed project. But it's fun, and glad to be able to have electrification really solve downtime. And I think it's a very common problem that we see, that I've always felt, and I've kind of always wanted to be able to go after projects like this more quickly, because it's such a classic thing. Like, when do you replace your water heater at a property, right? You replace it when it fails. And it has felt to me like on a lot of my previous projects that had, a couple months of design, and then, material procurement and installation, you're often bring a plant online 3, 4, or 5 months after contract signing. I think it's something that we need to figure out how to accelerate if electrification can capitalize on end of life replacements, because then owners are willing to spend money. They know they have to spend the money on a new water heating plant, and if we can figure out how to be faster, then we can capture those dollars that would have gone to gas equipment and have them go to electrification instead. So that's what I have for you today. And I haven't been looking at
You did a
the
great
questions, but I'll pause there and maybe Sean can help orient me.
did a
Thank you.
fantastic job. That's amazing. So Alice LaPierre, she wants to say, she notes, she agrees, heat pump water heaters do not currently work with recirculating water systems because the return water is too warm. Alice has been installing these in Berkeley. If there are models in the works that can accommodate pumped recirculating systems, we would love to know about those. Do you have multi-pass systems that you could be using as both the primary and the secondary heating system, or is that just not a thing?
Yeah, I mean, I think you got to get climate specific there. I mean, because I think about that too. But most of them so we're in Sacramento here, and it gets down to like 27 degrees. With some of these recent projects I showed, 25 degrees. In our 410A, just it doesn't go that low, and that's what's in a lot of the multi-pass systems, right? Whereas like what can get colder is the CO2 based heat pumps, because they have a much higher lift, and they can, I think I've seen the Sandco videos of like Fargo, North Dakota with snow, and it's still creating heat, which is great. So, you need something like that when the temperature gets below a certain level. So I think if you're in like, Los Angeles and Orange County, you might be able to do a multi-pass heat pump with a return to primary, or San Diego perhaps, but it's pretty limited application. Otherwise I think, you need to look at, a separated recirculation system, which is annoying because it increases the cost and complexity of the system.
Right. But it's what needs to happen apparently with all of our current stuff. Nick Patterson was interested in knowing about your screening practice. So you were putting in that gorgeous copper piping and all those heat pumps next to that window and the plants, right? You showed us. Do you put any fencing around it, or how do you?
Yeah, it's a good question. I mean, so this was the owner made that decision. I mean, the board made that decision about where to put it. We could have located the plant remotely, but the way the property's geometry is, it would have required trenching the hot and cold a significant distance. So I think you're referring to the fact that there's a window here, and the property didn't want to spend the money to remotely locate it. So we took care to, although you can't quite see it in this, to squeeze the tanks between the windows. And the view that they're giving up is actually the backside of a carport on the bottom floor. So it's not like a fantastic view. And so there was acceptance of that for that reason. But yes, we did discuss that at length. So it's a good question. And fencing, fencing could be put around the tanks in this particular instance, but we'd want to leave the Sandco units open to the air. So conceivably, we are talking with the owner about that. Conceivably, you could put a fence like this. This is really actually the most challenging building that we started with. The owner directed us to start there. Most of the other plants, it does not obstruct the window. This is just a particularly challenging one of the 17 buildings.
That's cool. It's still an impressive solution. You can still look out their window.
Yes, they can. They have clear, like, it does not obstruct the direct path of the window, although it is in the peripheral view. But like, if you drew a plumb line from the window straight out, it is unobstructed on both sides.
I'm trying to get you out of here on time, but the last question then is, what's the decibel rating for those units outside those windows? Because you were speaking about the noise.
Oh, it's quieter than the HVAC unit. There's another HVAC unit like right over here. It's quieter. It's the Samcos are the quietest. That's part of the reason we picked them for this application too, is they're, I think, 35, which is, they're really, really quiet. Sometimes the best way to know if they're on is with your sense of touch, to put your hand in front and feel that cold air blowing. Because it can be difficult to hear them. And when any other HVAC unit's on, you can't hear them. So yeah, but sound rating is an important consideration.
Nice, thank you. All right, good job. Hey, Andy.
Thank you so much for having me.
Thanks for your leadership, your technical leadership, going through all these incredibly challenging configurations of boilers, electrification, and showing us your journey, and thumbs up for where you are now, man. Awesome.
Hey, thanks, Sean. I appreciate that. It's fun. Yeah. Fun with the support of the amazing community that we have here on the Building Decarb list and your retreats and stuff. I've learned and worked with so many people on this call. So don't mean to say it's all just my experience either. Everything was together.
It is a really beautiful team effort. It is. You are a team leader. And so thank you for what you've been doing.
Thank you, Sean.